All right, let's solve this rational inequality. So we have x plus 5 divided by 1 minus x is less than or equal to 5. If you cross multiply this, you will get only one solution. I think you probably get x is less than 0, which is just one solution. So first of all, one thing we should take note of is that x cannot be equal to 1, because if x becomes 1, this fraction becomes undefined. So whatever solution we get, be aware that x cannot be equal to 1. Then how do we do it? We'll find a way of, you know, relating the inequality to 0. So how do we do that? We transpose this over here. And then we will have x plus 5 over 1 minus x minus 5 over 1 is less than or equal to 0. I want the expression on the left hand side to have the same denominator. So what am I going to do? Watch this. X plus 5 all over 1 minus x minus 5 into 1 minus x all over 1 minus x is less than or equal to 0. The next thing is to find the LCD. These are like fractions now, 1 minus x. So we'll just deal with the numerator. X plus 5 minus 5 into 1 minus x is less than or equal to 0. Simplify the numerator. You have x plus 5 minus 5 plus 5x all over 1 minus x is less than or equal to 0. So this and this is 0. X plus 5x, we have 6x all over 1 minus x is less than or equal to, this is 0. Now this is telling me that this fraction is less than or equal to 0. And remember that this x cannot be 1, or the fraction will be undefined. So this is simply telling me that this fraction is a negative fraction. And how do you get a negative fraction? Case 1, if the numerator is positive and the denominator is negative, that's how you get a negative fraction. And how do I express positive numerator? That would be 6x is greater than or equal to 0. If you divide both sides by 6, you notice that x will still be greater than or equal to 0. Or, and, not or, sorry, and then the denominator will be, since the numerator is positive, that's greater than, the denominator will be negative, that will be 1 minus x will be less than or equal to 0. Now, transpose this, you have minus x is less than or equal to negative 1. Now, divide both sides by negative 1. Negative x divided by negative 1 will invert this, is greater than or equal to negative 1 over negative 1. Now, we are left with x is greater than or equal to 1. So we found two sets of solution here, that x is greater than or equal to x is greater than or equal to 0 and x is greater than or equal to 1. So if a number is greater than or equal to 0 and that same number, set of number is greater than or equal to 1, this one defines this, because if a number is greater than 1, that number is definitely greater than 0. Now, our solution here will be that x is greater than 1. X cannot be equal to 1, because if it's equals to 1, this fraction becomes undefined. Now, there's also another way to get case 2. Another way to get a negative fraction, which is what we have here. 6x over 1 minus x is less than or equal to 0. Here, in this first case, we said let the numerator be positive. Here, we'll revert it to negative. If the numerator is negative, you have that 6x will be less than or equal to 0. So that makes my x to be less than or equal to 0. And the numerator will be 1 minus x will be here. This is less than 0. That means this one is greater than 0, positive. That means if I transpose this here, I will have 1 is greater than or equal to x, or x is less than or equal to 1. So if a set of number is less than 1 and that set of number is less than 0, this defines it. So in this case, this is what we select. In this case, this is the outcome. Combining our answer, we'll say that x is less than or equal to 0 or x is greater than 1. If you had cross multiplied, this is the only solution you will get. Now, representing this on a number line, we have 0 here and 1 here. This will be the solution, greater than or equal to. Here, x cannot be 1, so that fraction will be not be undefined. So this is what we have. Using interval notation, we are saying that defining this side from negative infinity to 0 using a bracket. This shows that this is part of the solution. Union, no, what we use here is this curvy bracket to show that 1, x cannot be 1 to positive infinity. This is our solution. Thanks for being a part of the video.